Okay, so I want to practice this just a little bit for you guys. I feel like this will be kind of straightforward for you, but I also want to practice it a little bit. So if we look at A says 3x plus 1 equals 3 to the fifth. This is similar to the one that we did earlier. These have the same base. The base is 3, so we can set x plus 1 equal to 5. So as we do that, we write the equation. We set x plus 1 equal to 5, and then we use what we know about algebra, and we solve for our value of x. B is a little bit deceptive, because what is our exponent on B? It's going to be 1. 6 to the first power. So as with many things in algebra, when there is no number there is a 1. So oftentimes we don't write the 1 in front of our x, right? It's just a given, that's what's there. So 6 to the first power is just 6, so our exponent here is 1. Okay, we're going to add 3 to both sides. We get 4 on the left and 2x on the right, and we divide by 2, and we get x equals 2. Okay, now let's do C. Oh, we do have some checking. That's a great idea. Plug your value in for x, make sure that they equal each other, because that's the whole idea, is that this is an equal sign. It means they equal each other. So finally, C, 10 to the 3x equals 10 to the 2x plus 3. These are the same base of 10, so we can set 3x equal to 2x plus 3. That's what we do, and we solve for our x, just like we've been doing for some time. Okay? So here we are in some other examples, and these are a little bit more complicated, because if you'll notice, let's look at A for starters. A says 5 to the x equals 125. So my question to you is, do we have the same base? And I would hope that you would say, well, no, the base on the one is 5, and the base on the other is 125. So the question is, can we make them into the same base? In other words, is 125, can we rewrite that as 5 to some power? Okay? The answer to that question is yes, we can, because 5 to the third power is 125. So now we've rewritten this as a function that has the same base. So 5 to the x is equal to 5 to the third. Now we can set x equal to 3, and that's our outcome. So we want to think about B in that same context. So we have one base is 4 raised to the x power, and the other base is 2 raised to the x minus 2. So can we change one of these into the same base as the other? And the answer is yes, because 4 is 2 to the power of 2. So as we rewrite this, that's how we want to think about it. So we have 2 to the power of 2 inside these parentheses. We want to think about what happens when we have a power multiplied raised to another power. We're going to multiply those two together. Okay? That's our exponent rules tell us that. So we end up with 2 to the 2x equals 2 to the x minus 3. Now we can set 2x equal to x minus 3 and proceed to solve for our x value. On our C here, we have 9 raised to the x plus 2, and we have 27 raised to the x. So our question is, can we rewrite one or both of these to the same base? So we know that 9 times 3 is 27, but we're not talking about just multiplying it by 3. We're talking about raising it to a power. So if we rewrite this 9 as 3 to the second power, and this 27 as 3 to the third power, I think we're going to get there. So let's take a look at the solution. They check. Great idea. We should all check our solutions, right? So here we have this problem C, 9 to the x plus 2 equals 27 to the x. So we're going to rewrite 9 as 3 to the second power. We know 3 times 3 is 9, right? We're just going to replace 9 with 3 times 3, which is 3 squared. And 27 is the same as 3 times 3 times 3. Now what happens with our exponent of 2 that's raised to the power of x plus 2, we have to multiply that through each of those. So we're going to end up getting 2x plus 4 on the left side. We're going to end up getting 3x over here. So 3 to the 2x plus 4 equals 3 to the 3x. Now we have the same base. Okay? Now we can set 2x plus 4 equal to 3x. And we can solve for our x value. So on this final example that I'm going to do for you, I need to talk especially to my freshmen just a little bit about how to rewrite a fraction using an exponent or a power. So we did do this very briefly last year. We hit it very briefly and you probably won't remember it, but if we have the number 1/2, we could rewrite that as 2 to the negative 1 because our negative exponents tell us that that number needs to go either down into the denominator or up into the numerator. So let me show you what I'm talking about. So right now these are not the same base, right? They don't look like the same base. So we have to rewrite this so that they are the same base. I know that 2 squared is 4. 2 to the power of 2 is 4. And so I want to think about how I can rewrite this to have the same base. So if I rewrite my 1/2 to be 2 to the negative 1, that's the same thing because what that negative 1 means is that my 2 needs to drop down into my denominator. So my 2 here, my 1/2, has an exponent of 1. 2 to the power of 1 is just 2. It's in the denominator. So that has a power of 1. I can rewrite it as a negative 1 and keep it up in my numerator. The proper place for it is in the denominator. So this is a bit of a concept that you haven't had a lot of experience with yet, and we haven't done a ton of work with that. So please pay attention to that detail. So we multiply the negative 1 times the x, we get negative x, and then we set up negative x equals 2 because we have this property of equality. Okay? Checking your work would be great. If I put in, I have to finish, I'm not done. I have negative x equals 2, so I have to divide by negative 1, and I get x equals negative 2. Okay? So again, let's take a look at B. B is a similar situation. So 4 to the third power I know is going to be 4 times 4 is 16 times 4 is 64. So this is, I could rewrite this as 1 over 4 to the third power. So see how they do that? Now I still don't have the same base, but I could write this as 4 to the negative 3, and that would give me the same base. This negative